Hey, I'm Adarsh, and for my final project, I am doing a question about optimization. Okay, so basically what optimization is, it's just maximizing or minimizing a quantity with some given values. Like an example would be like a farmer could be building a garden and he wants to maximize it with like a certain amount of wood. And like someone's building a house with just stuff like that. Okay, so my question is, a construction worker, his name is Kevin George, is asked to build a cylindrical tank, and he's given two instructions. The first one is that the net shape of the tank, when it is drawn out, the perimeter of the rectangle must be 30 feet. The second instruction is that the volume of the tank must be maximized. So what we want to do is we want to help Kevin find out what dimensions he should make the tank in order to maximize the volume. So the first thing we do is we have a picture, and so here you can see the cylinder, and then this rectangle is the what you would get when you unfold the cylinder, and that's what you want to find. So what we have in the rectangle is that we want to set up an equation for the perimeter, and so that would be 2x plus 2y equals 30. So now the first thing we will do is we will isolate y and solve to get that y equals 15 minus x. Okay, so now what we have is, you can see that on top the radius is r equals x over pi, and the volume of a sphere is v equals pi radius squared times h. So now we have what h is the same thing as y, and so here we have all of the quantities we need. So now we can plug them in to get that v equals pi times x over 2 pi squared times 15 minus x, which is the height. Okay, so now what we do is we would just simply expand this, which would lead to v equals pi times x squared over 4 pi squared times 15 minus x. So now we can do a couple things. First, we can cancel out this pi, and we can take out this one of the other bottom pi's. So now we have v equals x squared times 15 minus x over 4 pi. And we can also expand the top to get 15x squared minus x cubed over 4 pi. So now we can just, to find it, we can just take the derivative of this given equation, and so v prime would equal 30x minus 3x squared. And we can get that using the product rule with the exponents, and we can just leave the 4 pi there because it's a constant and it doesn't matter that much. And so we want to set this equal to 0 and then solve for x. So now this is just a simple algebra equation. If you want to, you can factor out a 3x on top to get 3x times 10 minus x. And when you solve, x is 0 or 10. And so we know that in this situation, x cannot be 0, because then it would just be like nothing. So we have that it's 10. Now, going back up to the top, we have this equation, y equals 15 minus x. So now we can use that equation here. X. And then now we can plug in x for it is 10, so y equals 5. And so the dimensions of the rectangle would just be 10 by 5. Okay, now there are two ways we can solve this. This is the first way, and it's the first way was the algebra, and this is the second way. And here we just have all the different data points for the given heights. And so by looking at this, you can see that obviously the greatest height would be here at h equals 5. And so you might be thinking, well, what if it was a value in between 5 and 6? Well, that's why we did the algebra, to prove that it was exactly 5. Another way of looking at this is if you plot the points, then you'll find that the highest point occurs at x equals 5, and that's approximately 40, which is like 39.7887, and so on. And the last way is we could plot the equation. We could graph the equation for the volume, and then looking at this, you can also see that the highest point is at 10, which is what we solved for x, and that makes sense because that's also about 40, which is the same as what we got in the last part. Okay, so thank you for watching. Have a nice day.